So welcome to this YouTube channel. And before I get started, I'm going to be kind of explaining what I'm going to be doing on here. So I'm in year 13 and I do maths, physics and further maths. So I'm going to be kind of doing walkthroughs of, the further maths papers, the A-level maths papers, physics papers maybe, STEP, TMUA, just kind of whatever. And yeah, I'm just going to be trying to get it all done and explain it all. So let's start with the 2019 FP1 AS paper. So yeah, let's get going. Part 1A just asks us to write down the T formula for sin x. And if you remember the T formula, that's basically just saying tan x over 2 equals T. And we can just draw out a triangle to work out sin x, but we should kind of know this result already as just being 2t over 1 plus t squared. If we were to do it with a triangle, we would basically have this. This angle will be x over 2. It will be right angle. And then, obviously, because we know that tan t is just t over 1. So opposite over adjacent. So the opposite will be t, and the adjacent will be 1. Therefore, the hypotenuse would be 1 plus t squared. Well, root 1 plus t squared. So therefore, we could obviously get our sin x over 2 and cos x over 2. I'm not going to do this, but you can kind of see how that would happen. And then we can just use our double angle formulas to make sin x and cos x. Cool. So part BI asks us to find the exact value of sin x when tan x over 2 equals root 2. So quite clearly, we're going to be using some kind of, t sub with the tan x minus 2. So if t equals root 2, which we can just do by making a substitution, then using our kind of formula for sin x here, we can just sub root 2 into t, and then therefore that tells us that sin x will be equal to 2 root 2 over 3. Cool. Part BII asks us to show that cos x is this. So we know the identity that cos squared x plus sin squared x equals 1. So therefore 1 minus sin squared x is cos squared x. So we can use that when we already know what sin squared x is. Sin x is going to be 2t over 1 plus t squared, so we can just square that to get this. Doing 1 minus that, we get this. And this is just where I've multiplied the 1 by this to make it become 1 plus t squared over 1 plus t squared. And then therefore, we can factorize both the top and the bottom to make 1 minus t squared over 1 plus t squared, all squared. And we know that's equal to cos squared x. So if we just square root that, it kind of gets rid of the squared symbol. And that just tells us that cos x is 1 minus t squared over 1 plus t squared. Cool. The final part asks us to use the t formula to solve this equation here. So, we have our sine and we have our cos. So this is sine and this is cos. All we have to do is sub that in, basically. So we sub it into each of the sine and cos. And then we kind of just expand out with the t squareds. And, make it a bit nicer. Turn it into a quadratic. And then we just solve that quadratic using calculator or whatever. Tells us t is 3 or t is minus 2/3. For the t equals 3 solution, that tells us that tan theta over 2 is 3. Taking arctan of 3, we get theta over 2 is 71.56. Of course, we can also have more solutions, but if we consider the range to be between 0 and 360, we're only going to have one solution for this value. Of course, we times it by 2, we get our theta as 143.1. Similar thing happens with the minus 2/3 as well. We get our, so the first solution we get will be negative. So if we add on 180 degrees, we'll get, our first positive solution. But then when we times that by 2, we're already at 292 degrees. So it's kind of clear we're not going to have an extra solution in that range. So therefore, our only two solutions are 292.6 and 143.1. Cool. So the next question is a bit simpler, I would say. We're basically just kind of evaluating what this person has done here and looking for the mistakes they've made. So first we have to identify the error made in line 3, which they've kind of nicely labeled for us. And And it's quite a trivial mistake, really. It's just all they've done. So they've factorized correctly, pretty much. They've taken out an x minus 24 and x plus 11. But they just haven't been careful with this x minus 24. It would have to be in a bracket. Because if you think about it, if it wasn't in a bracket, this sign here stays negative. Rather than becoming positive, which, will just give us completely incorrect solutions. So that's the first mistake. And then in line 7, what have they done? Well, it seems using their critical values, they're completely correct. But if you actually go on to check with these values, it turns out they've actually flipped the inequality and worked out when this side is bigger than this side. So yeah, I think the second one's a bit tricky to spot, but you can test this by subbing in a value between like 2 and 24, and then, yeah. So part B says find a correct solution to this problem. So we're doing this. Immediately, first thing we can do is note that x equals 24 and x equals minus 11 are going to be critical values to consider. So we don't have to worry about multiplying by x minus 24 squared on both sides and x minus 11 squared on both sides, because if we're already considering them, then they're kind of taken out of the equation. So if we just consider this here, where I've just kind of cross multiplied and made this an equal sign, we can solve both sides. Well, I guess bring it all to one side and then solve, and we get the solutions x is minus 4 and x is minus 6. So we have our 4 critical values, minus 11, minus 6, minus 4, and 24. And clearly, this is going to form a positive quartic because, these were our roots to the other parts, and these are our roots here. So if we multiply all the x's out, it's still a positive coefficient of x. Drawing our quartic, mine looks a bit hideous, but it is what it is. All we have to do is recognize where the graph is, greater than 0, yeah. So it's greater than 0 before minus 11, so in this region, between minus 6 and minus 4, and greater than 24. So we just write these 3 things in. Could do it in set notation. That would look like curly bracket x greater than minus 11, and then blah, blah, blah. Just keep doing that. But yeah, so that one was a bit nicer in my opinion. So the third question is about using kind of Euler's formula. And this formula comes about by basically saying, if we have 2 points on the same curve, we can kind of estimate the gradient just by using them and the height. So like imagine h is changing x and this is changing y. So our R0 and our T0 are 0 and 20. So therefore we can work out our dr over dt 0 by using this formula and just subbing in our R0 and T0. So doing that, we get that our initial rate of change is 40. So using this formula, which we can rearrange to get R1 is dr over dt 0 times h plus R0, we can sub in our, our R0, dr over dt 0 and our h, where our h is going to be a sixth. And we can work this out because we're using 2 iterations and we want to pass 4 months in that time. Therefore, each iteration is going to be 2 months. And out of a year, well, that's a sixth of the year. So therefore, using this formula, very easy. We just sub our stuff in and we get that our R1 value is equal to 80 over 3. Cool. So now we have our R1. We also have our T1 as well. And we know our T1 is going to be a sixth because that's the same value as our H. So where our T1 is effectively, T1 equals T0 plus H, pretty much. And we sub our stuff in to dr over dt1 this time with our R1, and T1. And that tells us that dr over dt1 is 53.997. And then using the same thing as before, we work out our R2 is this. Cool. So what we can establish now is that 35.66 is, that's less than 40. And the requirement for her to sell her rabbits was 40. So all we have to say now is just, no, pretty much no. She won't have enough. Yeah. Cool. This question is about vectors, and in my opinion was probably the easiest question on the paper. So yeah, let's do it. So first thing to do, work out the area of ABC, which is this triangle down here. And we can easily do this just using this formula, which you'll learn. So all we have to do is find two vectors that are kind of next to each other. So we do AB and AC. Very simple. AB, we just do kind of the position vector of B minus the position vector of A. Same with AC. And we have our two vectors here. Now we're just crossing them together. And we cross effectively. I'm not going to go into too much detail, but that's the same as the determinant of this matrix here. You can prove this by kind of expanding everything out and doing a whole lot of nothing, but yeah. And that tells us that our AB cross BC, or AB cross AC, sorry, is 18I plus 36K. And of course, to work out the area, we have to take the modulus of that. And that gives us 18 root 5. And then, of course, we divide that by 2. And we get the area is 9 root 5. Cool. Now here it tells us that the volume of this doorstep is 21 centimeters cubed. So that tells us that this whole shape here has a volume of 21. And to work out the area of a shape like this, we have to use this formula. So a sixth times the modulus of AD dotted with AB crossed with AC. So yeah, that's just another standard formula to remember. And you know, we can work out our AD using the position vector minus position vector method. We get this. And then all we're doing now is we're dotting this AD with the cross product of those two vectors, which we already worked out up here. And that gives us a sixth of 36D minus 90. And of course, this dot product here will give us a number, not a vector, because, yeah. And then, so the modular signs are only here to make sure we don't get a negative number. That's what I'm trying to say. And of course, this is equal to 21, which tells us that 36D is 216. So D is just going to be 6. Cool. Last question now. So we're given this rectangular hyperbola, and it's going like this. And what it tells us is we have a point, and these are just kind of the parametric equations for x and y. And it tells us this area created by this line, which is a tangent, is 32. And it also tells us that the length OB is twice OA, which is very, very nice of them. So that tells us that this length here, OB, is, 2K, if we call OA K. So first thing to consider, if we want to find the gradient of this tangent, I'm not really sure if we have to do this, but it's fine, we can do it. So dy over dx, differentiating implicitly, and using the product rule, we just get dy over dx is minus y over x. So at the point P, it's minus py over px. We don't really have to use that, to be honest. I don't know. And we also know the area of this triangle here is going to be given by k squared, because it's 2k times k over 2. So that tells us that k squared is, 32, and k is 4 root 2. So now we know the intercept of this curve, and we know the gradient. Thinking about the gradient, we know that the gradient is change in y over change in x, and of course the change in y is minus 2, and the change in x is, minus 2k, and the change in x is k. So that just tells us the gradient is minus 2. And of course the y-intercept is just 2k. So our equation of that line is minus 2x plus 8 root 2. Cool. Now all that's left to do is work out our value of c up here. And how do we do that? Well, we know the coordinates of py equals 2px. And I guess this means we did need to use this thing from before. So yeah, that's good. So what we can do, using the parametric equations for x and y, we're basically saying that 2 times the x coordinate equals the y coordinate. Getting rid of our c's, we get that t squared is 1 over 2. So t is root 2 over 2. So therefore, our equations for x and y are these two. So these coordinates, x and y, they're not only present on the hyperbola, but also on the straight line. So we already have the full equation for the straight line. So we can just kind of sub these points in to this thing up here. And that nicely tells us that c is just going to be 4. So we have c as 4. So now we know this equation is just xy equals 16. So now we know that xy is 16. We have our y point here. And this is also equal to y. So we can just sub that straight in. We get this quadratic, which we can just solve for x. And that gives us the repeated root. X is 2 root 2. And because y equals 2x, y is going to be 4 root 2. So the point P is just going to be 2 root 2, 4 root 2. So yeah, that's the end of this paper. Thank you for watching, and I'll be sure to upload more videos soon.